All right, today we are graphing logs. Okay, it's really, really kind of easy. Okay, so the parent function is f of x equals just log of x. All right, as it says here, a log function is the inverse of an exponential function. Using your graphing calculator, we're going to sketch these two. So you put it in the calculator. We should know by now, but just in case, you go to Scratchpad, graph, menu, 3, 1, and then you just type it in. Okay, you don't have to write y or f of x, just type in log of x. So we type in log of x, we get this. Ooh, actually, it slopes a little bit. It goes like that. Okay, little point right there. And then f of x equals 10 to the power of x. It looks like this. All right. One thing you'll notice, I'm not an artist, but they're supposed to be the inverse of each other. Okay, they're the exact inverses of each other. So, oops, went way down. Looking at number 1, we have f of x equals log 2 of x. There's two ways to do this. You can either graph it in the calculator, sketch it, look at it, know what you're looking at, and get the answers. Or you can graph the inverse, all right, and then fill out a table and then do the inverse that. But if you know how to graph it, all you have to do is just graph it. So in the calculator, Scratchpad graph, menu 3-1, you graph it, you put it in, you got log 2 of x, and then you hit enter and you see what it looks like. It looks kind of like this. It's hugging this line, and then it comes up. I want to make sure I get this right. Passes through here and then goes on its way. It looks just like that. Okay? Now we need to do the domain, the range, the end behavior, the x-intercept, and the asymptote. We should all know what that means. Okay? End behavior might be kind of new, but it's not that bad. Okay? Our domain, looking at it, the domain, remember, is x, so it's going across this way. So it's going across, the graph is not here, the graph is not here. We hit 0, and then we see the graph. So the domain is x is greater than 0. It's not equal to 0 because if you notice, it never actually passes 0. But as soon as we pass 0, we get the graph. So x is greater than 0. It's not equal to 0, but it's greater than 0. The range is all real numbers, or negative infinity to infinity. Because we see it's going down, it's never going to stop going down, and it's going up gradually, and it's never going to stop going up. All right, now end behavior. As x approaches infinity, so as x approaches infinity, it's going that way to infinity, y, which is f of x, is also going to approach infinity. That's all that's saying. All right? And now as x approaches 0, see how x approaches, as x is approaching 0, f of x, y is going towards negative infinity. That's all that's saying, okay? Now our x-intercept, again, just looking at the graph, I'm not an artist, but I made sure to pass through the x-intercept. The x-intercept is 1, 0. We should know that by now. And then the asymptote, remember asymptote is where it doesn't cross through. The asymptote is x equals 0. And that's it, we're done. All right, you know me, I don't like to take up too much of your time. I think us doing 1 is enough. Okay, on number 2, you just do the same thing. Put it in the calculator, log 1 over 3 of x, and then you hit enter. And then from there, you just need to be able to know what you're looking for. All right, finish the rest of this, turn it in.